All right, hey everyone. Thanks so much. I'm Francis Pouliot. I'm the founder of Bull Bitcoin. Bull Bitcoin is a non-custodial, Bitcoin-only exchange founded in Canada about 12 years ago. And I want to talk to you about the philosophy of Bull Bitcoin first. So we have a philosophy when building products and applications, and just as a general company ideology that we call the hard path. And here I have a little graph to explain what the hard path is. So our goal is to scale the Bitcoin user experience, to make it better, to make it available to a wider audience. We're not talking about necessarily orange pilling the masses, but we're talking about getting the most amount of sovereign-minded individuals into Bitcoin. And to do that, the traditional easy path to get people into Bitcoin is to do compromise. So if you want to get more people on your app, if you want to orange pill the masses, a lot of people are talking about making these compromises. And at Bull Bitcoin, we have what we call the zone of acceptability of potential compromises that we're willing to make. And as you can see, it's very small. And what we want is we want to get to a target outcome where you have large-scale Bitcoin adoption and amazing user experience without going up on the compromise scale. Of course, the ideal outcome is to have no compromise whatsoever. Everybody's running their own node. Everybody's having a hardware wallet multi-sig and trading on peer-to-peer Bitcoin exchanges. This is zero compromise, but it's really hard to get to scale and good UX with that. So we're trying to get into that zone where we have large-scale Bitcoin adoption with the least amount of compromise possible, and that is very hard to do. So that's why we call it the hard path. So when I talk about compromising, what do I talk about compromising on? We're talking about compromising on the cypherpunk ethos, which can be summarized as being absence of third parties, trust minimization, censorship resistant, permissionless, anonymity and privacy. So these are the goals. This is what we want to maintain as much as possible. And in practice, when talking about using Bitcoin, we're talking about self-custody of your coins, ideally using your own Bitcoin node. So our mission is not to get people into numbers on a screen. We don't sell MicroStrategy shares. We don't sell paper Bitcoin. We want to create sovereign individuals. And the core of sovereignty in Bitcoin is self-custody. There is no feature of Bitcoin that you can think of that is not itself derived in some shape or form from self-custody. Our goal as a company is to identify the issues that people face with self-custody and to solve them. And the sandbox that we're playing it with is application-level user experience. We're not talking about changing the protocol. We're talking about creating apps and services which solve these issues for people. And there's four main issues with self-custody. There's fiat on-ramp and off-ramp, or in other words, buying and selling Bitcoin. So we've already solved that. Bull Bitcoin is the largest non-custodial exchange, I think, probably in the world. We were the first bill payment service in Bitcoin. We operate in multiple countries, so we've already solved that. The other issue with self-custody is payment speed and cost. We all know Bitcoin transaction takes a long time to confirm. It's not really useful to pay for coffee with an on-chain Bitcoin transaction. And there's some issues with Lightning. So we've built a wallet, the Bull Bitcoin wallet, and we pioneered one of the concepts that is becoming very popular now amongst Bitcoin wallets. It's using second layer or bare asset networks like eCash. We use Liquid, and we use a strategy of liquid swap. So we've already solved, to a large degree, the payment speed and cost. And the two issues remaining for us to solve are Bitcoin wallet backups and inheritance. So these are the four main issues with self-custody. And wallet backups are a problem. It's easy to say, it's easy. All you have to do is write down 12 words, and then you have a Bitcoin backup, and then you're safe. And the whole reason why we have wallet backups is because there is device and application loss. So the keys are on your phone or on your laptop. It can be lost, damaged. You can delete an app from your phone. The application data can be corrupted. You lose access to your PIN on your phone. If you don't have a backup, you lose access to your Bitcoin. There's some kind of bug with the wallet, and you need to re-download it. So the solution to that was the mnemonic wallet backup, BIP39. So this was invented back in 2013. So that's the solution to the Bitcoin wallet backup problem that Bitcoin community came up with. But there are a lot of issues also with seed phrases. It's the weak point in orange pilling someone. Maintaining and securing a seed phrase is a new responsibility that is not obvious to all the users. A lot of people download a wallet at an inopportune moment. Think you're orange pilling your friend, it's 2 a.m., it's in a bar. It's not the right moment to tell someone to write down a seed phrase. It requires a complicated explanation, and a seed phrase must be well understood. So I've been orange pilling people for 12 years. I've installed probably somewhere close to 10,000 Bitcoin wallets. I know that sounds insane, but I've installed a lot of wallets. And when I orange pill someone, I have to go through the list of everything that they can do to get screwed. So that's not a really great experience, right? Because I'm telling someone, okay, if you don't do a backup, you're screwed. If you lose your backup, you're screwed. So you should buy a metal plate, and you should buy 2 and sort them in separate locations. If someone finds your backup plate, you're screwed. So you should add a passphrase to your backup. But if your passphrase is not strong enough, you're screwed because someone can brute force it. So you have to use a strongly, randomly generated strong passphrase. But if you lose your strong passphrase, you're also screwed. So you have to write a copy of your passphrase. But if you store the passphrase at the same place as your backup, you're screwed. So you need to have 2 hiding places, one for your backup, one for your passphrase, and you need to have 2 copies of the backup. It becomes really complicated. I'm not saying that this is impossible to do. I'm not saying that it's actually that hard. It's just I'm thinking about the kind of people that I orange pill, which are everyday people that want to use Bitcoin. This is a complicated way to introduce them to Bitcoin. So there must be a better way. And of course, the market has come up with all sorts of solutions. Well, the number one is Bitcoin's not for you. So if you can't store your backup, a lot of people say, well, it's not for you. People use fiat financial instruments that are borderline Ponzi schemes and scams like MicroStrategy and all sorts of ETF stuff. People will leave them on exchange. They'll leave the coins on Coinbase. They will use professional custodians. And then down the line, you have retail custodial wallets like Wallet of Satoshi or Blink or Bitcoin Jungle. You have collaborative custody like Casa. You have multi-sig key recovery services like BitKey. And you have some really interesting and awesome solutions as well, like Liana. You have mini-script-based multi-sig with time lock recovery paths. But none of those solutions fit on that UX compromise scale that I like. Either they compromise too much, or either they don't scale, and the UX is not that good. So let's design a new way to do backups. So what are the goals in designing this way to do backups? Well, Bitcoin users should be uneducated, unwise, unmotivated, unskilled, or incompetent. They should be drunk, okay? So this is something I want to do. I want to do something that is good for all these people. Anonymity is inseparable from security. So any protocol or service or product that handles backups must absolutely prioritize user anonymity. The backup should be done in 2 minutes because you're orange pilling your taxi driver, you're orange pilling your friend. They must be able to do a backup in a couple of minutes. They should maintain their security and anonymity regardless of the location or device of the end user. You should not have a specific device. A service that does backup should not hold private keys. If a service that helps users do backup holds a part of the private key, they can be considered a money transmitter. The services should be free or extremely cheap. There should be no vendor lock-in. So if you offer a service that helps users do backups, it must work with other devices and other apps, not just yours. You shouldn't have to buy special hardware to do a backup. You should be using regular software and hardware solutions. So these are the design goals. And these are some observations that we have in designing this system that I'm about to introduce. A properly encrypted digital file is the safest way to protect a Bitcoin mnemonic from theft if the encryption is strong enough to prevent brute forcing, and if it's performed in a device environment that is at least as secure as the one used for generating keys and signing transactions. Humans are bad at creating passwords. Any encryption key should be randomly generated with sufficient entropy. We cannot expect Bitcoin users to memorize randomly generated encryption keys. Humans are bad at backing up their data generally. Password managers, for most people, are a convenient and secure way to back up their passwords. They are ubiquitous. Cloud storage providers are, for most people, the best and easiest way to back up data to protect against accidental loss. I think probably most of us use a cloud service. Probably most of us use a password manager. They are part of people's habits. And Bitcoin users are more likely to be targeted by attackers than non-Bitcoin users. So we've come up with something that we call Recoverable. On recoverable.com, you can see basically everything that I'm explaining now. and I'm going to show you first what it looks like inside a Bitcoin wallet to use Recoverable to back up a wallet. Can I play this video? Yes. So you're creating a new wallet. There's no Bitcoin in it. There's no nothing. You receive Bitcoin. You see that now you have to back up your wallet. You will choose the encrypted vault option. You will choose a vault location. Can be Google Drive, can be any custom location. Now we are signing in to Google Drive. Cool. The wallet is connecting to Google Drive. You're going to pick a password. The password is going to be very simple. Not a complicated password at all. Just a regular PIN. The wallet is connecting to the key server over Tor. I'm going to explain to you how that works. Backup is complete. How do you recover the wallet? I'm deleting my wallet. I'm going to recover a wallet. Cool. Start from scratch. Choose Recover Wallet Backup option. Again, choose Encrypted Vault. Choose Google Drive. Sign into your Google Drive. Backup is there. Decrypt. Enter your PIN. Connect to key server over Tor. Wallet recovered. That looks very easy. That looks very simple. Now I'm going to explain to you how it works in the background, which is a lot more complex. So first, we start with a seed. It's generated on the user's device. Then, from the seed, we derive a 256-bit key using BIP85. So this key is derived from the seed. Therefore, it's randomly generated, and it's very, very long, impossible to brute force. If you are able to brute force this key, that means you are also able to brute force a wallet backup anyway. Then we encrypt the backup, the mnemonic, with the key that we generated using AES. This gives us an encrypted mnemonic. We create what we called an encrypted vault, a backup file, which has, you can see in bold, this is the encrypted mnemonic. We have the path, the BIP85 derivation path. We have a random salt and a random ID. So you have on your phone an encrypted backup file and an encrypted backup key. It's on your phone, so you need to at least put the file somewhere else. So you're going to connect to either your Google Drive, your Apple Cloud, your Proton Drive, or you're going to save it to an external laptop or an external phone. What you're going to do is you're going to take the encrypted backup file and you're going to store it somewhere else. In the example I showed you, it was Google Drive because it's the most convenient. It's the one that almost everybody has. Now, the user inputs the password that I put, 1971-2009. What we do is from that password, we take the salt, right, that is in the backup file, and we generate with a hashing algorithm called Archon2 an authentication key and an encryption key. And also, we have the identifier from the backup file, which is randomly generated. So now we have an encryption key that encrypts the backup key, and that gives us an encrypted backup key. So the backup key that we generated with BIP85 is encrypted with the encryption key, which is derived from the user's password and the salt. And now, that's where it gets interesting. There is something called the Recoverable server. The Recoverable server is like an anonymous password manager. It's a web service. The wallet connects over Tor to this server, and it will upload to this server the encrypted backup key, which is the user's the key that's derived from the mnemonic that is encrypted with the user's password and his salt, and the identifier. So the Recoverable server will take the authentication key that we created, client side, create a key ID. That's kind of complicated, but it will store the encryption key of the user in its database alongside a key ID. And what's really important here to understand is, okay, so you have the encrypted backup, which is hosted on the user's drive, and you have the encrypted backup key, which is hosted on this service, the Recoverable server, and there is nothing linking those two together. Both of them are fully anonymous, so the ID is not the same as the ID here because it was tweaked with the salt. So you have a file which hosts the encrypted backup, and you have a file which is on your drive, and you have a file which hosts the encrypted backup key, which is handled by this recovery server, which is a free service available that anybody can run. So You lose your phone, you start your phone again. How does it work? The first thing you're going to do is you're going to import your backup file from your drive, or if it was saved on your other computer or your other phone, you're going to just add that to your phone. Then it's on your phone. Then you're going to input your password again. We're going to regenerate on the phone your authentication key and your encryption key. So now we have the file, we have the authentication key, we have the encryption key, and we have the identifier, which are derived from the file and your user input password. We're going to go back to the Recoverable server. We're going to say, hey, here's my authentication key, here's my identifier, give me the backup key. This Recoverable server is going to send you the encrypted backup key based on your authentication key, which is essentially authentication to the Recoverable server without an email account, just using that authentication key that was generated on your phone using your password. Same process happens. OK, cool. Now your phone downloads the encrypted backup key. You have your encrypted backup file. You have your backup key. It's decrypted using your password. You're back with your seed. So the security model of this backup strategy is a segregated 2FA2 backup to prevent theft. There is ubiquitous storage, so you can save it anywhere. You can save it in your drive. You can save it on your phone, on a laptop. You don't have to secure it in a special place to prevent loss. There is client-side encryption with high entropy keys. So the key that is used to encrypt your backup is a high entropy key. But of course, that's why we have the recovery server, because if the key has high enough entropy, nobody can remember that encryption key. So we use the key server to store people's keys. The key server uses rate limiting. So that's the core security part. So you can only do 3 requests at the key server per day. So even if your password is 8 digits long or even 6 digits long, a hacker can't get the backup key, because after 3 attempts per day, you can't get the key. And even a 6-digit PIN requires a million brute force attempts to get it. Users are fully anonymous. The key server doesn't know who you are. The key server doesn't know where your backup is being stored. Your drive doesn't know where your backup key is being stored. There is full anonymity in this service. There is 0 authentication or 0 KYC at all. And it only works over Tor, so not even the key server has your IP address. And the key server can remain anonymous. So this concept was based on another project called Photon SDK, which was invented by a developer called Tancred Hayes. We thought it was really interesting, but we thought that we could do it in a better way, so we re-implemented the Photon SDK. So I just want to give credit to this guy called Tancred Hayes, which came up with the idea of the recovery server and of hosting an encrypted backup in your drive. So recoverable.com is an open source project. So the client library is written in Dart. The server is written in Rust. Both of them are open source. Of course, we encourage any wallet developer to implement it. On recoverable.com, we have a white paper, which is about 30 pages long, which also covers what we call a threat model. So we look at everything that could potentially go wrong: state-level attacks, hacks, your wife getting access to your drive, you losing access to something. So on recoverable.com, we go through all the lists of the threats and all the catastrophic scenarios and how our protocol implementation specifically addresses all of them. And it is implemented in the Bull Bitcoin wallet today. In order to access it, you need to tap on the Bull Bitcoin logo 7 times. So you can download the Bull Bitcoin wallet on TestFlight or on Android or on APK. You tap the Bull Bitcoin logo 7 times, and it will unlock recoverable.com, because we're still in beta testing mode. Important to note, this is an alternative to custodial exchange accounts, custodial wallets. It's an alternative to physical backups for hot wallets. It's an alternative to passphrases for physical backups. It is not an alternative to long-term cold storage. It's not an alternative to hardware wallets. It's not an alternative to multi-sig. You're not supposed to use this for your life savings. This is something that you would use on your mobile device and when orange pilling someone. And that's it. I'm done. Thank you very much for your time. Exactly 20 minutes.
Secure your BTC Prague 2026 ticket at the lowest possible price now.